Hello, good afternoon. Welcome to the class ECE341 Probability and Stochastic Process course. Today we will study the multiple random variables. You can also think they are vectors of random variables. All right. Of course, we start from the second order, from the two-dimensional case. All right. ECE341. This is for the ninth week, Monday's class. And we say multiple random variables. Multiple random variables. It is just, you have more than one random variable. You have several random variables. So we consider the 2D case firstly, of course. We give the detail for 2D case, two-dimensional case. Consider two random variables, x and y. Now we have two random variables. We consider them together. Then, of course, the things related with x and y, we already studied before, right? All those things will be we still have those things here. So we still have the following. We have the CDF. That will be fx of x, fy of y, right? We still have CDF. Then if they are discrete type, then we still have PMF, probability mass function, the px of x and the py of y. So things like everything will be double, right? We have two. And then PDF. This is a case for continuous type. We have fx of x and fy of y. Right? This is the discrete type. This is for continuous type. Usually we consider both x and y, they have same type. Like both are discrete or both are continuous. Of course, maybe some application you need to consider, like one is discrete type, one is continuous type. But here in this course, we only consider they are in the same type. So both are discrete type or both are continuous type. And other than these three functions, we also have some numbers, right? So we have mean of x, then of course mean of y. The variance of x, now of course we have variance of y. And if we take square root of variance, we have the standard deviation of x and standard deviation of y. Alright, so we still have all of these. Yeah. Oh, I think they're a lot. Yeah, it's a lot, but the way to calculate them is not very difficult, right? Okay, now we have more because we have two, so we have more. Yeah. First is about the functions, right? Other than these 6 functions, we have another 3. Each contain both x and y, so we call it the joint functions. The joint CDF, denoted by fx and y of x and y. Now this function is related with both capital X and capital Y. It will be the probability of, or similar with the CDF. It is x no more than lowercase x and y also no more than lowercase y. So this is CDF. Alright. And we also have joint PMF. PMF, similar. We have both x and y. It is defined as the probability of capital X equal to x and capital Y equal to y. And then we have joint CDF. That will be lowercase f x and y of x and y. There will be, okay, this is a density, right? It's a density. Or not CDF, sorry, PDF, probability density function. This is density. So density you can think like you consider as an area in each unit area, how many weight on it. That is a density on weight, right? This is similar thing. So this is a of course we need to consider limit. Limit third tend to be 0, and here is a fraction. Numerator is a probability. So this is density of probability, and the denominator will be an area. Now we choose a small piece of the event of the sample from the sample space. Or pick a small event. Let's say capital X minus this x no more than that over 2, and capital Y minus y is also no more than that over 2, and divided by delta square. So we have joint PDF. This meaning is like you check the whole space. This is x, this is y. You can think this is the whole sample space, right? Whole sample space. Now we check. Here's a capital X equal to x and capital Y equal to y. Then nearby this point is a capital X equal to x and capital Y equal to y. We choose a small area. We consider the event, this as an event. Then the probability is this one. The area, okay, we use this here. This distance is dirt. Okay, the x is in the center, so capital X minus x no more than half of dirt. And similar here, we also, this is also dirt, right? Dirt, distance is dirt. Then the whole area of this rectangle is delta square. So in this small area with the area delta square, we have this probability. So this is kind of a density in this small piece, right? Small rectangle. And we want to check the limit, so we let delta tend to be 0. Of course, this is only happen for positive dirt. Okay, so we have this one. They are the definition. They are the definition of these three functions. And by this definition, we can obviously we have these. Actually, we discussed these kind of things in the calculus, right? So we know f(x,y) of x and y equal to d squared over dx dy of f(x and y), x and y. We have these. And f(x, y) of x and y, this is a derivative. Then the other side, right, will be integral from negative infinity to x and negative infinity to y. Here will be f(x) and y. Okay, I separate them. This is okay, this x is x will change from negative infinity to this x. So I put a tilde here. Alright. Yeah, this is not exactly that one. This is a x tilde will run from negative infinity to x. And y is similar, will run from negative infinity to y. So I put a tilde. The dy tilde, the dx tilde. Oh, sorry. I need more space. Okay. So this is relation between capital F and lowercase f. Right? We have these two. Alright. These are functions. Right? Joint function related with both x and y. And also we have number. we have one more number similar with these, but we have the adjust function and the joint average. Joint average, there will be COV of x and y, which is defined as expectation value. This is the mean, right? Mean of x minus EX and y minus EY. And this here is this means we call it covariance. And another is just R. People sometimes use COR or R, just R. I think we're fine. R x y. This is E just x times y. This is called correlation. Correlation. Yeah, this is correlation. So it's R, capital R. So we have some. This put the E here means average, right? So it's a joint average. Okay. All of these are definitions. So when we have two random variables, we have a lot of things. You see, first of all, for these fx, px, fx, and variance and E and standard deviation, all of these we have double, right? We have for x, for y, for x, for y, right? Double. And other than these are the old steps, right? We already know that. And now we have something new. We have joint CDF, PMF, PDF, and also the joint average. Oh, we have another one. It's rho and rho xy. Rho xy will be a kind of is the covariance of x and y divided by sigma x, sigma y. Yeah, this one, covariance. This is just called as a relation. I forgot the name. Okay, so next time I give you the name. Forgot the name. Yeah. So we have these three. Okay. Now we study some examples to see what happened for these kind of things. All right. Actually, the concept is not new. You know, it's a kind of these are old concepts, right? And this one is a kind of generalized, right? For CDF, if you only have x, you have this one, capital X more than x. Now you have x and y, so you need a both, right? Yeah, this is also both. So it's kind of a generalization of these single variable case. In the textbook, that is chapter 5. Put this out. Chapter 5. But in the textbook, it is discussed all these things. They discuss the step by step, similar like when we study these kind of things. So one section about the CDF, one section about the PMF and discrete type. Then those EX variance X variance Y for discrete type. Then PDF, then continuous type, and all this in continuous type case. And everything they have one section. But I think I list all of these together here. Then you know, okay, what we were studying right now, right? You have all the things. Then following will be the details about it. We can use example to discuss all of these kind of things. Okay, example. I consider example. We have a similar example before, right? Like you consider phone call. You statistically phone call as a long call, brief car or medium car, and also as like a digital car or a traditional car, right? You have different way to separate it. So actually those different way you can think they are two random variables. So we can describe that as like this. I have a x, I have a y, and here's a probability. X could be value like a 0 and a 1. That means digital car or phone, traditional phone car, right? And here will be a brief car, medium car, or long car. And then the probability, for example, this probability depending on the statistics, the company phone call, they recorded the phone call and they have the state. I just put it here, imaginary, 0.2, 0.3, 0.3, too much, 0.1, 0.15, 0.2, then okay 5, totally should 1, right? Totally should 1. This is distribution of the 100%. So this is 50, 2, 3, 4, 4, 5. Okay, point. All right, just like this. Okay, so this one gave us a joint PMF, joint distribution, right? So all of these give us a joint distribution. Joint distribution, right? Actually, it's a PMF now. It's a discrete type. And then we can have we want to know the like x. We want to know the probability of x. Then we do summation, right? We do summation here. So this one I do summation. I have 2, 3, 4, 5. 45%, and this is a 55%. I have this, and similar for y, I have this one. This is a 0.5, 0.3, 0.2. Okay, so this column, actually this column is py of y, right? This column, and this column, this is a px of x, right? Px of x. And in the middle part, that is a PMF of both. It's a joint, right? It's a joint one. And then we have name. We call these py, y, and px, x. They are called as the marginal distribution, marginal PMF. So we have a name for it, right? They're in the margin. We call the marginal one. Yeah. This is a name related with it. Yeah, just a name. We call them the marginal one. All right. This is a joint. These are the marginal. I have two direction marginal. And then by this way we have we can discuss the relation between pxy and the px and the py. So here pxx if pyy equal to pxy of x and y if these x and y they are independent. Now we have a concept related with the marginal distribution and the joint distribution. If we have this relation, they are independent. Then for this one we can check whether they are independent, whether these x and y they are independent. You can times these two numbers to see whether they are same. Okay, here's the difference, right? Like here's a 0.5, this 0.45, you times these together should be 0.225. But here's a 2, they're different. So here, x, y, they are not independent. They are not independent. And what else can we have? Okay, we can check the mean value. This is not for just for this example. This is in general. This is also in general. All right. And we can also calculate those mean values. We have EX. What is EX? That will be same thing. You have the PMF of X, so you can have the mean should be 0 times this number probability, and this 1 times the probability, so it's 0 times 0.45 plus 1 times 0.55. Okay, so this is the mean of X. And mean of Y will be similar thing. There will be 0 times 0.5 plus 1 times 0.3 and 2 times 0.2. There will be how many? This is 0, this is 0.3, this is 0.4, so 0.7. Okay, this is mean of Y. And we also have the variance, right? The variance of X, there will be E of X squared minus square of EX. Okay, of course we can calculate it use a similar way. So this one will be 0 times this and 1 square times this, right? We can also do in different way. We can use the joint distribution to find it. So we can calculate this like this is for X, right? So X be 0, we have these three things. So I can as 0 squared times 0.2 plus 0 squared times 0.1 plus 0 squared times 0.115. Not 115, it's 0.15, right? We can work like this. And plus 1 squared times 0.3 and 1 squared times 0.2 and 1 squared times 0.05. We can work like this. We do not use this part. We use this probability. It should be same, right? Use summation. They are the summations. So you use they are summations, right? They are summations for X. They are summations. You can do the summation before you calculate, or you just calculate directly. You do not add them together. Yeah. Okay. So this one you can know. This is also 0 squared times summation of these three, right? So this is a 0.45, and this is a 1 squared times the summation of these three, so 0.55. Yeah, it's the same thing. Okay. So out of these and minus EX we already have is 0.55 we square. So this is 0 times this and 1 times this, so it's 0.55 minus 0.55 square. Okay, I can write this is a 0.55 times 1 minus 0.55. So it's a 0.55 times 0.45. What it is? 4555 25 2 20, right? 5525 4 is 20. So 2475, and the 2 point, so totally 4 points. So 0.2475. So we have variance of X. And if you want, you can also want this one. There will be square root of 0.2475. Yeah, something like that. And similar, you can have variance of Y equal to something. I don't calculate it here. All right. If you are interested, you can finish it. And sigma Y, the standard deviation, equal to what kind of thing. And then we have some more variables. We have the covariance of X and Y. what it is. This is a e of x minus ex times y minus ey. Okay, this one can be calculated by this one. This is the formula: ex times y minus ex times ey. This formula is similar with this. You see, if x equal to y here, then here will be x squared, right? If x equal to y, this will be square of ex, right? Yeah. So this is the formula in general. A formula. So every time when you need to calculate this one, you can use this formula. Now I have ex and ey, right? I have ex and ey. So only thing is I want this one. For this one, you have to use the joint distribution, right? You need both x and y and the joint probability here. So we were equal to exy will be summation of all the value of x times y. So I have 0 times 0 right here, right? 0 times 0 with probability 0.2. Okay. And 0 times 1 with probability 3. And similar, 1 times 0 with probability 0.1. And 1 times 1 with probability 0.2. Yeah, you just follow it. 2 and 0 and probability 0.15. And 2 and 2 and the probability is 0.05. Alright, 1, 2, 3, 4, 5, 6. 1, 2, 3, yeah, 6. Alright. Yeah, this case you have to use the joint distribution. You cannot use this because this part they are only related with value of y. For different x they mix together, right? Now you have to separate each case, so you can only use the joint probability, the joint distribution. Okay, then what will be the result? Now actually here is not hard because we have a lot of zeros, right? This is 0, this is 0, this is 0, this is 0. So we already have these two numbers that are non-zero. So first is 0.2, and this is 4 times 0.05 is another 0.2. Okay, so 0.4. So this is exy, and also we need a minus ex times ey. Okay, ex is a 0.55, ey is 0.7. So 0.4 minus this is what 57 and 3a and point. So this is a 0.385. Alright, so the subject I got 0.015. Yeah, it's a covariance. We call this a covariance of xy. And of course at the same time we already have this one is exy, right? Exy is what? Is rxy. Correlation of x and y is 0.4. We already have it, right? This is a exy. Yeah. And if you want more, you can also have that as rho xy. It will be covariance over sigma x, sigma y. Oh, I didn't have sigma y. So yeah, I leave it blank here. Okay, so this is the one example for discrete type, and we can do similar thing for continuous type. We check another example. Now we suppose like we have random variables x and y. We have joint distribution, they have joint continuous, right? So they have the PDF, joint PDF, f x and y, which number will be good? Okay, I suppose for both x and y smaller than 2, between 0 and 2 they have some value here, and 0 otherwise. So that means the density only when x and y, their values between 0 and 2, we have positive, we have densities, kind of density. So what kind of density I can put? Like a k, x, and y. Yeah, I need to determine the k. Which k will be good? Okay, I just put like this. Then we can find several things. The first one, of course, find k. Yeah, make sure what it is. Yeah, determine it. Now it's just it looks like this one, right? Determine k. Find k. And secondly, we want to find the marginal distribution. Marginal PDF now is PDF fx of x and fy of y. We want to find these. In this case, they are somehow complex. We need to find the CDF before we do this one. Let me see. Okay, and the third one, we want to find the some like those values. Actually, we can have different values. Like we can find the probability of x between. Okay, I suppose consider the x between. So x plus y. Now this may be too complex. Let me see. Yeah, just x plus y smaller than 1. Alright, we consider this. This is probability. X and y, capital X, capital Y. The summation of these two random variables, I want to consider the event, the summation smaller than 1. Summation of them smaller than 1. Okay, so, and of course the force, we want to find the EX, EY, then the variance, the covariance. Okay, just like this. Depending on time. If I have enough time, I find all of them. If I can't, I leave it to next time. Alright. First one, we need to find this k. Now, what is this k? So the principles are the same. The overall probability should be 1. So now is we have density here. Density, so we integral solution. The density, overall integral of the density should be 1. Yeah, should be 1. That means the probability of the whole sample space is 1, right? We need this one. And for this one, you can think that this is sample space, right? The sample space from both from 0 to 2. So this is a 0 to 2 for like x, and also 0 to 2 for y. Right? And this one is k times xy. So this is 0 to 2. This is a k times x and y. Right? This is a k times x and y. When we do integral on y, then k and x, they are constant. So keep them, nothing change. And the y will be y squared over 2. Here's a run from 0 to 2 dx. Okay, 0 to 2 k times x. What it is? 2 put 2 here, plug in here, there are 2 squares 4. 4 over 2, I get 2. And 0 plug in is still 0. So it is just 2, right? times 2 and dx. And then I move k in the front. Okay, x2 I can put them together. x2 related with x squared after integral, right? So kx squared is 2 to 0. So it's 4k. Right? 2 squared is 4. 4k. 4 minus 0, 4k. 4k equal to 1, so k is 1/4. Okay, we get a k. Alright? So we know this is a 1/4. K is 1/4. And secondly, we want to find the marginal PDF. So how to get the marginal PDF? Fx of x. How to get it? Yeah, you need to think about it. We have this, right? We have this. From 0 to 2, 0 to 2, we have some non-zero probability here, and all the outside is probability, the density is 0. And fx is along this direction, right? This is x, this is x. So you want to find the fx of x here. Now how to do it? Actually similar with the discrete type. Discrete type you do summation, right? You do summation in this direction, you get fx, you get the mass function, probability mass function. Now we still do the summation along this direction. Alright, but now it's an integral, right? Because you have infinite numbers, you do integral. So this is just the integral from negative to positive infinite. Yeah, negative to positive infinite. Actually here just from just on the do summation along this piece, these pieces, so 0 to 2, right? 0 to 2. Yeah. And then the function, the overall, the joint density dy. So after you do this, after this integral, you will have a function only contain x. That is just that one. Alright, so we can try. This is integral just run from 0 to 2, and this is k times xy. K is 1/4, so it's xy over 4 and the dy. Alright, now we can have it. This is x over 4 times y squared over 2, and y run from 0 to 2. 2 squared is 4. 4 over 2 is 2. 2 cancel with this 4. I have another 2 in the denominator. So this is x over 2 of x. Okay, now you can double check. You can see fx from 0 to 2, right? Just from 0 to 2. Outside should be 0. Yeah, here's a 0 smaller than x smaller than 2. And okay, this is fx. This is x. Here's a half of x, right? It's like this. No. Like this. Slope is half, so here should be 1. Okay. This is fx. Is it good? Sorry, I don't need this. It is good. You check the integral of this. Can you get 1? I will say yes, right? The integral will be the area of this. So this length of this bar is 2, and here's 1. So the whole rectangle has area 2, and this is half of the rectangle, so it's 1. This area is 1. So this one do integral, you will have 1. That's good. Yeah, that's good. This is a valid density function for a single random variable x. Alright, and similar, fy of y. This is also integral of the joint density function, but this time we do the integral related with x, according to x. After integral we have y left. Alright, then this one will be integral from 0 to 2, and this is xy over 4 dx now. Then this is a y over 4 times x squared over 2, and x run from 0 to 2. So it is similar. This is 2 squared is 4. 4 cancel, I have 2, is y over 2. And of course we want y is between 0 to 2. Okay. This time the integral like this. 2, this is x, this is y. You want the integral like this in this direction, right? Along this direction. For fixed y, you do integral along this direction, you have the marginal distribution of capital Y, right? Yeah. Yeah, same with this. All right. Okay, so this is the marginal distribution. Okay, then third one, we want to find the probability x and y, do summation. Oh, by the way, we can check the independent, right? Independent. If fx x times fy of y equal to fxy of x and y, then x and y, they are independent. This is also in general. This is for continuous case, continuous random variable. In general, all right. And for this example, are they same? You see, it's same, right? Fx is half x. Fy is half y. You multiply these two together, you have xy over 4. Right. So in this example, because fxx times fyy equal to fxy xy, so x and y, they are independent. All right. Yeah, just for this example, right? This is independent. This is general definition, and we know they are same, so they are independent. Then we check next one. We want to find this probability x plus y smaller than 1. To summation smaller than 1. What it is? For this kind of things, you give a graph, there will be help. So we should have this, right? From 0 to 2, both x and y, from 0 to 2, you can think this is the whole sample space, right? This is the whole sample space. And x plus y smaller than 1, where can we have that? So like this is 1, this is 1. So both x and y will be smaller than 1, right? If x is somehow smaller, you can choose some y here. So actually, I give a line, a straight line like this. It will be this area. It will be this area. This is the x plus y smaller than 1. All right. So that means you can think this is the event. This is the whole. This is sample space, right? You have event. Then you want the probability of this event. Now, how to do it? You also like we do integral. Here's a x plus y smaller than 1. Lowercase x and y smaller than 1. Here's a density function. Now is a k. K is 1/4, right? X y over 4 dx dy. This is a joint density function. X and y. Sorry, x and y, x and y. Right. And this area should be this one. So you also need smaller than 1, and x should be positive, y should be positive. Right. This is the bound. This bound according to x is positive. Right. X is positive, and this is a y is also positive. Both x and y are positive, and summation no more than 1. So this part. Okay. Now the problem is how to write the upper and the lower bound of the integral. You can have, now you have both x and y, right? You can choose one first. So like I suppose I do x first. I choose x first. X can run from 0 to 1, right? This is x. X can run from 0 to 1. And when x is given, you can check y. Y will run from 0 to here. Okay, so let me write down. X will run from 0 to 1. Dx. And y will run from, when you have x here, y will run from 0 to this point. So 0 to this point. What is this point? What value of this point? This point, according to x plus y equal to 1, so y equal to 1 minus x. So here is 1 minus x. Make sense? You can check more. If x is 0, if x is 1, here x is 1. If x is 1, then you see here's 0 to 1 minus 1. So the integral from 0 to 0, nothing, just 1 point, right? And when x decrease to here, like suppose this is 1/3, and this point will be what? Also 1/3, right? So when x go down to here, this is 2/3, right? This 2/3. Here will be 1/3, 2/3 and 1/3. So if x is 2/3, 1 minus x is 1/3. It works, right? You can try. You can pick like here, when x is very close to 1, then 1 minus x were very close to when x very close to 0, y were close to 1, right? Yeah, so always like that. Okay, so this is for y, and then here you need to put that density over 4. But here you can see you have some confused, because this is also x, this is also x. So usually this case you need let me see, do we need to make some change? This is for dy, you do the integral, and then you do x. Oh, it's fine, you don't need to change. You do the x. If I put this is x tiered, this is x tiered. Make sense? Sorry, I'm confused by myself. I think I don't need. Yeah, just 1 minus x will be fine. 1 minus x will be fine. Okay, now what it is? This is 0 to 1, and the integral for y. So x and 4, I keep it out, and y will be y squared over 2, and run from 0 to 1 minus x. So this is a integral. Here's x over 8, and y squared is 1 minus x squared. Oh, it's this one. Okay, so this is I need a times. X over 8, this is 1 minus 2x plus x squared dx. So this is 1/8. I move in the front. And here's x minus 2x squared plus x cubed dx. Okay, each term, the first one is x squared over 2 minus 2 of x cubed over 3 plus x fourths over 4. And run from 0 to 1. So I only need the one term, right? 0 is nothing. 1, so this 1/8 times 1 over 2 minus 2 over 3 plus 1 over 4. So what it is? 1/8 times, I use 12, right? 3, 4, 12. So this is a 6 minus 2 fourths 8, and plus 1 is times 3. Am I good? This times 4. Okay. So this is a 1 negative 2. Okay, it's 1, right? 6 minus 8 is negative 2. Negative 2 plus 3 is 1. So numerator is just 1. Denominator is this one times 8. So 1 8. 2 8 is 16. 1 8 plus 1, 9. 96. Oh, it's a very small number. Okay, so this one gives us the probability of this event. Alright. Okay, that's the time. So for this part we can calculate next time. Alright. Yeah. Alright. Okay, that's all for today. Have a good day. Thank you. Bye bye.